Hello, everyone. My name is Tamasi Benjamin. I'm studying at Budapest University of Technology and Economics, and I'm going to be giving a speech on hacking CCTV systems. I hope you're all ready. This is going to be lots of fun. I hope to do lots of demos, and I hope everything's going to work great. So, first, let's see, what is CCTV exactly? CCTV is closed-circuit television, and here's a nice description by Wikipedia. But CCTV is basically security cameras, at least in our case. So security cameras and their networks. So here I have a nice little analog camera, which you can see here. So many happy people. And this is hooked up to a DVR, a digital video recorder, which is what we're on now. Probably this will seem more familiar. Yeah, back to slideshow. So, which is the digital video recorder. But it's important to note that the same can be done with IP cameras. They're very similar structures. So this is our target today, the iDenavision DVR. But first I'm going to start with a story of how I got into hacking CCTV systems. Well, my dad works in a company which buys and sells CCTV systems, alarms, and he brought me home one day this iDenavision DVR, which I have here. And I remember I spent many sleepless nights on it. And, well, basically he brought it home and he said, son, we forgot the password, and you're going to have to hack it. So I got right to it, and I started reverse engineering the firmware and everything. And then he had a really great idea. He said, why don't you try the password 1, 2, 3, 4, 5? And amazingly enough, it worked. Why? Well, that's a very secure password. I mean, we use it all the time. And the funny thing is, 99% of these DVRs, which I have recovered passwords from, have used the password 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, which is just a little bit more secure. So, already demo time. Let's check out the basic usage of this DVR, and then we'll check out our network analysis with Nmap. So we'll switch here to the DVR, and here you can see the picture from the camera. And let's see what we can do. Well, here we have a login with an admin. And if the password is not 0, then it's usually and we're in. So 1, 2, 3, 4, 5, nice secure password. So what can we do with this? Well, the main function of this DVR is actually to record the video. And in the advanced settings, you can check out the users. So we have a basic admin account. And yeah, he's the one with 1, 2, 3, 4, 5. And then we have guest and default, which are basically not really good for anything, but they use them. And this is about all that's documented. So this is what people use, this system. And they have a web interface for this whole thing. So if I were to open a web browser and type in the IP address of this DVR, then I can have access to a nice little web graphical user interface, of course, if it loads. Yep, there it is. OK, so we're greeted by the same screen, and the password is the same. So we can log in. And we can check out this nice page. We can view the cameras. If we run QuickTime, Yeah, and I'm going to start off with my favorite part. I found an interesting bug, or feature as some would call it, in the web user interface, which basically consists of, if you don't know the password, let's say we don't know that the password is 12345. Let's try Hacktivity as the password. It's going to throw back an error saying, sorry, wrong password. OK, let's try that again. Empty password. Right, second time, no good. Let's try the third time. Still no good. Fourth time, still not good. Fifth time, still not good. OK, what about the sixth time? What do you think is going to happen? Who thinks the same thing is going to happen? Put your hands up. Same thing. You can get the same message. OK? Who thinks Batman's going to appear? Who thinks I'm going to get logged in immediately by some amazing magic? Well, you were right. It threw me back again. OK, what about the seventh time? Who thinks Batman's going to appear? Who thinks I'm going to get an error exactly the same as I did so far? Hands up. Ha, you're all wrong. OK. Who thinks I'm going to magically log into the system? I do. Oops. So, bug or feature, I don't know, but that's a great way to log in. And yeah, the funny thing about this, though, is that it doesn't work. Like, you can log in, but if I try to view the cameras, it won't let me. So basically, this is not really good for anything, unfortunately. Although I never tried the PTZ functions for moving the camera, because this camera is unfortunately cannot be moved. But there are certain cameras which can be rotated and zooming and everything. Maybe that works, but I cannot see the picture from the device. Anyway, maybe this is a honeypot, I don't know. But it was something very interesting that I found. Anyway, let's then do a simple analysis with ZenMap, because we like graphical user interfaces. Let's do an intense scan and check out what it gives us. By the way, the documentation for this DVR basically only talks about the graphical user interface, which is built into the device. Actually, the device, while Nmap is scanning, I'll switch to this device. It has a nice little feature which works against brute force. So if I log out, and I try to log back in, and I don't know the password. Let's say I try the empty string a few times. No, unfortunately, 7 times doesn't work here. OK, we get a very nice sound saying I tried too many times. And this actually activates all the alarms. And I don't know if this was actually the 7th time, so this might be some crossover to the web user interface. And it says the account has been locked. So if I try logging in with this password, it again triggers the alarm, even though this is the right password. Cool. Let's switch back to Nmap. OK, it's doing the service scan, so we'll have results soon. But we can already see right here that port 23, 554, and 80 is open. OK, we know port 80 is open because that's running the web user interface. But what is port 23 doing here? I didn't see that documented anywhere. When the service scan is finished, let's check back. I actually don't know how long it blocks it for. I usually just reboot it, and then it worked. Well, we can check again. Actually, they have a nice little remote control for it, which doesn't work without a battery for some strange reason. OK, so it still doesn't work. I'm guessing it's only after a reboot that it works, or maybe after a longer period of time. But we'll reboot soon and we'll check it. Nmap is almost finished its service scan. OK. Let's switch back to Nmap. And OK, it's not finished yet, but while it's scanning, let's check out that port 23. So I don't know, most of you probably know, but if you don't, 23 is mainly used for telnet, which is a more secure version of SSH. No, it's not. OK, so this DVR's saved it. It's on this IP address. And we're logging in with telnet. Let's see what it gives us. OK, localhost login. Let's try the admin user, as I'm guessing that's probably what it will be, even though it's not really documented. OK, what's the password? 1, 2, 3, 4, 5. And it's not going to let me in. Not because it's locked, though. We can try rebooting it soon and see. But it's not going to let you in. So this uses some kind of login, which we don't know and is not documented anywhere. And if you ask the vendors, they'll deny it. OK, Nmap's still scanning. Now let's go then to switch to our backtrack machine. How can we get this password for this device? Well, basically, any software which is running on the device is stored on this chip. I don't have hardware for removing that chip and reading all the information from it, but I have a firmware upgrade. And a firmware contains basically what's running on this device. So if I can somehow extract the information from the firmware, which I need for this device, then maybe I can find some information on how to log into that telnet to reset the password 1, 2, 3, 4, 5, because I already forgot it. So funny thing is that on their website, if you go to the Idenovision website, at least I couldn't find any firmware updates, but you have a Hungarian company called LDS, which is selling these devices. And they had a web page where I could download all the firmware upgrades. So I downloaded a few. I'm working with a little bit older version of firmware because that's what I tested it on, but this pretty much works for the newest firmware as well. And what I'm about to show you doesn't just work on this device. The scary thing is it works on 99% of the devices. So this whole telnet function is something that they really like doing. And I'll tell you why. So let's say I forget the password for this device. What would I do if, for example, here's a TP-Link router. If I forgot the password for this, what would I do? I would probably press the reset button on the back, or ask someone who remembers the password, or try 1, 2, 3, 4, 5. But the reset button will probably fix it, because it will reset to default factory settings. However, this DVR does not have a reset button. As much as I tried to find it, it's not there. Why? Because if you forget your password, why would you want to just reset it yourself when you can pay a bunch of money for other people to do it? So the basic procedure for resetting the password on this, if you forget, you send it back to the company, pay them money to log in via telnet with a password that they already know, but we don't know. And not yet, at least. And they will reset your password for you. But I don't want to do that. I want to reset it myself. OK, Nmap should have finished by now. And yes, it's done. Anyway, here are the ports. And there is a BusyBox telnet daemon running on port 23. So that's all confirmed. Now, let's get to the fun part. Reverse engineering the firmware. And there's probably a page in my slide for that, but the rest of my slide basically just says demo, demo, demo. So, all right, let's get to the firmware. So, I downloaded the firmware. Now, what does the firmware look like? Like this. It's a binary file. Not much to do with it. You basically upload it onto the device, and it flashes itself. So, let's see what this binary file is. We can run a really nice tool called file on it. And it tells us that this binary file is actually basically just zip archive data. So we don't need to be scared by that .bin file extension. It could basically just be renamed to .zip. And it'll do the same thing. So, well, in Linux, we don't have to rename it. We can just unzip it like this. And here are my files. These are what I unzipped. We have a custom X cramfs.img and some other stuff. And here's a file which is called install-desk, which is just ASCII text. So let's print that out and see what it is. OK, so these are upgrade commands telling the DVR to burn this to the flash. So this is basically just commands for it. Nothing really interesting in here, except here's a hardware identifier, a vendor. general. That gives us a lot of information about it. So let's see these other files, though. There's 1, 2, 3, 4 image files in here. The logo X actually contains a logo, very surprising. So that's not of much use to us. Let's check out the ROM FS, because that sounds like it would be something interesting. And here it's important to know if this firmware has been encrypted with something or compressed with something. We can run strings on it. Actually, no, first let's run file on it to see what this is. So file tells us here that this is a U-boot PPC boot image. Now, if I would search the internet for this and try to mount it, and after hours and hours of trying, it didn't work. I couldn't get it to work. And I wondered why. Because if I run strings on it, strings give me a bunch of weird stuff, so basically nothing readable. But after searching a long time on the internet, first I'll show you guys the way I did it, which took me about 2 days, and then I'll show you the proper way to do it. No, we're not going to spend 2 days doing this. It's a little faster now. So by searching online, I found a website talking about these U-boot PPC images, and it was about hacking flash disks or memory something. Anyway, it said that this U-boot, which was identified by file here, so this U-boot PPC image is actually a compressed image with 64 bytes of header in the beginning. And we can actually check this with a hex dump. And we can see in the beginning, see, I'm sure you all know that this is the magic file. I didn't know it, but here, this first 64 bytes of data is basically just a header. And then comes a compressed ROM. So if we can get rid of the 64 bytes of header, then we should be able to mount it with no problem. Because right now, if I try to mount this image, let's try to mount this image, see what happens. Okay? Okay, sorry, not a block device. We need a mount minus O loop. I must first specify the file system type. Okay, let's not do this. Let's instead remove the 64 bytes of header at the beginning of this file. We'll use DD for this. We name the input file, which is ROMFS. Let's name an output file, which is going to be just simply romfs.out. And then let's tell it to skip the first 64 bytes of data. Okay, so it basically skipped the first 64 bytes of data and it's parsing it all bit by bit, byte by byte actually, and it's going to spit out a nice little file without that bothering 64 bytes of data at the beginning. So now if we run file on it, on this romfs.out, which is basically the same file just with the first 64 bytes of headers stripped off. Then we get a Linux compressed ROM file system data. It's a completely different image file now. And luckily for us, we can mount this. Okay, we just mounted it. Let's check out what it looks like. Cool. I don't know how much the green you can see, but I can open it up here in graphical interface so you can see it better. So we mounted it here. And this is what it looks like. So we just mounted this file. And it looks like a pretty complete Linux system to me. And if we know where to look, we can find interesting files. And then we can display their contents. And we can find password hashes. And interesting thing about embedded systems, though, because usually most Linuxes these days, if you would open this password file, you would not find a hash here. Someone know why? Yeah, that's right, shadow. Well, embedded Linux, unfortunately, doesn't know much about shadow because they don't implement it very much, at least not in these systems. Actually, I checked, I think OpenWRT, which is for embedded Linux for firmware for the routers, they only just started using shadow as far as I know, but correct me if I'm wrong. Anyway, in our case, we have a cool hash here, which is not shadowed. And this is a simple des hash. But if we don't know what kind of hash it is, then we can always just give it to John, and he'll tell us. So let's put it in John's. Actually, I'm going to put the entire line into John. Put it here into his hash list. And then I'm going to run John. Windows, Alice. OK. Let's run. I'm running just normal John, but you can also run John OMP, which is basically the same thing, except it cracks in multiple threads, which makes it work a lot faster usually. So here we'll just specify the hash list for it, and that's it. That's the whole command, john.exe hash list txt. And it will tell me, loaded one password hash, traditional DES 128. So here we can find out that this is actually a DES hash. Now, if we were to let John crack this, he would probably crack this in around 3 hours, at least on my laptop, which is not so good. But it does crack it after a while. However, if you would use another program, for example, OCL Hashcat, for me it cracked it in around 17 seconds, a little bit faster. Anyway, I'm not going to crack it now, since I already cracked it at home. But I cracked it and got a really cool password, which looks like this. I was actually thinking about whether to show the root password or not. And then I searched for this exact password on the net. And I got a Twitter post with someone posting it. So it's already out there on the net, so it's actually nothing new. Anyway, this is a cool root password. Let's try to log in with it and see what happens. Oh yeah, and we got the username from here, root. So let's try doing that. OK. Who thinks I'm going to be logged in immediately? Hands? Who thinks Batman's going to pop up? Who thinks it's going to give me an ugly error saying, you're not authenticated? Oops. So we're in, and we're root. We basically just hacked into the device with a known password hash, with a known password extracted from a hash which we got from the firmware. And it didn't take us a long time to do that. And with OCL Hashcat, 17 seconds cracks the the password hash. So that was pretty easy to do. And now that we're in root, we can take a look around the system. Yeah, it looks pretty much like the firmware we took apart. And I'll show you how to do that in a couple minutes. I'll show you what you can do inside here with root. But first, let's check out another. Say I didn't know that the header was exactly 64 bytes because no one put it up on the net. And yeah, how would I guess that? Well, there's a really awesome tool for that. In fact, that really awesome tool is going to automate this entire process for me. Let's switch back to our home directory and go back into the firmware. OK, so here are all the stuff I extracted. Now I'm going to show you a really cool tool called binwalk. If we run this on the firmware, say, let's delete that romfs.out that we did. OK, so this is just the stuff extracted originally from the binware file. Sorry, from the binary file, which was basically just a zip. And let's run binwalk on it. Let's see what it tells us. OK, binwalk here tells us that here's a uimage header, which is 64 bytes long. So I don't have to guess that next time. I know exactly how long the header is. And it even tells me a bunch of very important information about this. It tells me the header size, the CRC data, this is just the header CRC. But the header also stores some things such as the data entry point and the data CRC. So if I wanted to make changes to this firmware, say I wanted to make some custom firmware for this device without Telnet turned on or with maybe a different password, which is actually a really good idea. I haven't done it yet, but I'm definitely going to. And then this CRC data would need to be changed with the corresponding CRC of my modified data. So that's nice to know that this is exactly 64 bytes. And actually, this uimage header, if we check it out in a hex dump, we can see exactly all this information where it was taken out of. And interesting story is, before I stumbled upon this binwalk solution, actually, the funny thing is that when I started working with this binary file, I did it the hard way. I finally got it to work, and as soon as I finished getting it to work, I found a way to do it easier. And same thing with this. I only found binwalk after I had already reverse engineered the whole. Well, I wouldn't actually call it reverse engineering yet. Anyway, let's check out what binwalk can do. Binwalk has a very nice function. If we give it the capital M and E command, and we just, okay, let's get rid of the extracted data. Let's say we only have the binary file, right? We want to automate every single step of the way. We don't want to do any hard work because we're lazy. Okay, I'll remove this install. So we only have the binary file left. Then we run binwalk with this capital ME parameter, switch, sorry. And what this will do, this will automate the entire process for us. So binwalk will basically take a look at the image. It'll say, okay, this is a zip image. It'll extract it. And then it'll take a look at the extracted image. And it'll say, okay, what is this? And it'll find 64 bytes of header at the beginning, and it'll find the rest of the data at the bottom. And it'll be smart enough to separate that and extract what it can. So if we run this, it'll run all by itself. We don't have to do anything. We can sit back and relax and watch it do its hard work. And it does everything for us, and it's already finished. And now if we check back, we find a nice little directory with everything extracted. So now if we go back into our ROM-FS, we can see here that it has extracted everything for us. So here's that Linux system, all nicely in green, just so you can't read it. And this is the whole thing. Like we can go to TC, and we can check out the password file. And then here's our root hash. So this whole thing can be automated for us. And yeah, so this is a really simple way of doing it. Actually, binwalk has a bunch of really nice features, which I'm not going to get into all now. But it has something called the string search. So I can run binwalk with a minus capital S parameter, and it will give me all the strings that it can take out of this binary file. Now, it's not going to extract a lot from this binary because it's still compressed, but I got some interesting information. And after extracting it, I can go into the extracted directory and check out all these images. I can, for example, go to the ROM-FS, and use binwalk minus S, ROM-FS, and it'll give out a bunch of strings, which is really nice. These are basically all the files that are inside, and I didn't even have to extract it. And if we use this like this, then we can get the exact location of root, which is cool. Okay, so now that we reverse engineered the firmware, actually one interesting thing about this firmware first is that it has a very interesting file called sophia.exe. Now what is an exe file doing on a Linux system? Someone have any idea? My theory is they ran out of Linux developers and they found a C# developer because there are just so much more C# developers. Yeah, so they have an exe file, which I didn't reverse engineer yet because I'm not really good at reverse engineering exes yet, but it's planned. Okay, so now we're in root in the DVR system. I'll just switch back here to see that basically nothing has changed. Same picture. So the DVR has no idea it's being hacked. And let's check out some stuff we can do. Okay, so first I'm just going to reboot the system first because it might still be on lockdown from trying the wrong password too many times. Yeah, it has a nice little sound when it reboots. And meanwhile it's rebooting, I'm just going to show you something really cool. See these gloves? Guess where I got them from? They gave it with the DVR, so I can keep my hands clean while hacking. No, it's actually for handling the hard drive. Interesting. Anyway, I just brought it to show you. It might be interesting. You get a nice pair of gloves if you buy this DVR. That is, if you buy this DVR. OK, cool. That means it started up. And we'll log in soon. OK, so we're in root. Now, say we don't know the password's 1, 2, 3, 4, 5, right? So let's just make sure the password is actually still 1, 2, 3, 4, 5. Cool. So that works. We're in. OK, but let's say we don't know this, and we want to reset the password. How would we do that? Well, if we know the master password, then we can just list out what's here. And we go to the MNT directory, which is the mount directory, check out what's here. OK, so here's basically web contains all the stuff for the web graphical user interface. USB contains USB mounts, because they have 2 USB ports in the back, which you can use for firmware updates, logo, DVS custom, and basically what's interesting for us is the MTD. OK, so we have a nice folder here called config. And if we check out what's inside that, we get these. And I think this one's going to be interesting. Actually, when I first got this DVR, it had 2 files called account 1 and account 2. I have no idea what the second one does, but the first one definitely works. So let's look inside this account file. And I was actually amazed that this password was not in clear text. It's hashed using something. Did I skip over it? Users admin here. Admin's account password. OK, this is some kind of hash, a very, very long and secure hash, as you can all see. But we don't need to crack this hash right now, as if we check out mount, we can see that where we are, MNT is mounted as a read-write system. So we can make any changes we want to this. We can put a new hash inside, or we can just simply remove this file. Let's see how the DVR likes this. Let's first try logging in 1, 2, 3, 4, 5, the right password. It's going to work because it didn't reboot yet. But on next reboot, and after a nice little sound, we should be able to log in with no password. Because if it doesn't find this account file, sorry, switch back. If it doesn't find this account 1 file, it automatically resets to, well, factory default settings, which is basically just an empty null string for the password. So we can log in with no password. Let's see how that works after the nice colors. OK. And we logged in without any password. So that was it. We just have to delete that account file, and we're in. Cool. OK. Now, why is this scary? Because these things are actually being used. And it's not just Identivision. There's nothing wrong with them. They basically make similar products to other stuff. I can list CP+, a bunch of other vendors. They make the same stuff. And they all use this telnet password. OK, theirs is not the same, but they also have a master password. And it's commonplace to use master passwords, but that's not really a good idea. Because you just saw how easy it was to reverse engineer this and to extract the master password, and that's all I need to do. And basically, any Identivision product that I'm going to use will use this password. Whether a DVR or IP camera, they all use the same master password. So from here on, if I go somewhere, anywhere, to some company which uses this, all I need to do is get on their LAN somehow, and I can basically log in to the DVR. If I know the password, I can log in via telnet, and I can do anything. Like, It's mounted, if I mount a different point, like if I don't touch the account, but let's say I can wipe the entire contents of the hard drive from here, which basically means that they have no security footage anymore. So all the security footage that was taken will be just gone, because you can delete it with one command. And I can modify data. And I know it's kind of hard to modify video files and put it back. That's not really, but I can also clear logs. I can basically do anything because I'm root. And maybe that's not a too good idea if anyone can be root with just knowing this short little password. And this is the same for, I repeat myself again, most of the DVRs use this. Like most of the things, they all have master passwords that you can all log into them via Telnet. And yeah, you're root. You can do anything you want. They each have a different password. What, you go home, reverse engineer the firmware, get the password, crack it, and you're in. And yeah, so, but let's think of a solution for this problem. Well, I would say the first solution is don't use a master password. That's probably the best way. And even if they would use a master password, why use the same password for every product? Or at least make a way for us to turn off that telnet function. Like I would put some kind of switch inside it, which you would, or some button or something, that the telnet could only be turned on if you bring it back to the factory. Or better yet, just not use telnet and put a reset switch on it. That would be the best idea. But then, not so much income for the iDynavision. So, another method, if the companies don't want to change, you can always make custom firmwares for it, which is not actually that easy, but it can be done. And in the custom firmware, basically, you can change your telnet password to whatever you want. In fact, you can even disable the telnet daemon inside the firmware. So you can essentially make your device completely secure. And why is this important? Well, these are security systems. We expect them to be secure because they basically, what they do, they take care of our security, we can say, but they store all the data from our video cameras, they're an essential part of our security. And if they're so easy to hack, then why are we using them? They give a false sense of security. So, but anyway, they have a really nice picture, so it is useful for some things. And basically all that would need to be done to make this really secure is for just for vendors to change this telnet setting, and they would be really cool. Not to mention that also these devices, if we go back to ZenMap, this one, for example, doesn't use any specific ports, but there are some more advanced DVRs which use special ports because they have special software which works with them, and this is mainly proprietary software, which is known for bugs. So that can also be exploited. And I don't know actually anyone who actually looks at these systems and tries to hack it. Like so many hackers are hacking. We're hacking computers, we're hacking mobile phones, we're hacking all sorts of things, but I never actually met someone who works with hacking these security systems. And that's why I thought it would be interesting to show this to you guys now, that it's actually not that hard. You saw how simple it was. And yeah, this is what's being used today. And that's the level of security. So my suggestion is either get the vendors to fix this, or actually I don't really have any other suggestion because I cannot tell you to buy a certain type. I don't know exactly how many types of DVRs are there, but most of them, like I said, use this technology. So basically, they're all not secure. And we can take a look at a newer firmware. I downloaded firmware actually for many more devices, which we're not going to analyze all now, but they all have the same vulnerability. The best firmware actually I found so far was a Samsung's firmware. And why was it so good? Well, it was encrypted and I couldn't open it. So I have no idea what's inside. But yeah, one more interesting thing about this DVR is that if we take it apart, I'm not going to take it apart now, but if we take it apart, actually we find that this whole box, which is about this big, the board inside is only around this big. So most of it's just empty space for the hard drive. And there are active debugging ports on it, which means that I can essentially attach. Sorry, see ya. Okay, I'm going to have to give a speech for. I'm going to have to stay here for 5 more minutes, and then we're all going to see something really, really cool. So I'm going to quickly think of something else to talk about for 5 more minutes. Okay, so what I didn't prepare for this show, but it will be a very interesting topic, is to hack into this system, not over like there are some systems maybe which we cannot have access to this way, where we cannot do this way, but we can get access straight to the board if we connect hardware into those debug ports. You can buy for a couple of dollars on eBay a nice little converter which will plug into your laptop with USB and plug into that with just like 3 pins. And you can connect it to your computer, and when you start up the DVR, you'll immediately see the U-boot running down. You press Control-C, and it stops the whole thing, and you're basically root. And you can do exactly the same thing which I did right here without even knowing the telnet password. So you don't even have to reverse engineer anything. You basically just connect to it, and you're in. You're root. It doesn't ask you anything because, well, if I took the whole thing apart and I'm in, then. And you can do the same thing. Like if I wasn't able to reverse engineer the firmware, if I'm in with root, then I can do the same thing without the firmware. I can just, if I'm in with root, I get a terminal shell, and I can just cd to the etc pass wd file and open it and read this hash and crack it the same way. And that's another thing which can be done. Now, on the CP plus DVRs, which I checked, I couldn't find any debug ports, but like I said, they are also vulnerable to this, well, I wouldn't call it a telnet attack because it's basically nothing special. There's just a telnet open on it, and I connected to it. So this, I don't know. I wouldn't even classify it very much hacking except for maybe reverse engineering the firmware, because basically all I did was just read a hash. And maybe cracking the hash could be considered hacking, but this is basically normal stuff. Like, you don't have to be super smart to do this, because this is actually my first time reverse engineering anything. I started with EXCs, didn't get very far, but this was pretty simple. Like, I just read tutorials online, how to do it. I checked out binwalk. Binwalk is a really cool tool. I'll show you something else with binwalk, just to keep the counter going. She's going to come back soon. So binwalk actually comes pre-installed with Backtrack. How many of you use Backtrack? Just show of hands. Have used Backtrack, know what Backtrack is, have seen Backtrack here? Okay, so Backtrack is a really cool distro, and it comes with binwalk pre-installed. However, I had to install the binwalk separately because the pre-installed version, first of all, doesn't come with a magic file. Now, the magic file is the part of binwalk which actually defines how binwalk can find the stuff in firmware. It's a little collection of things that binwalk knows what's what in the firmware. So you can download binwalk from the binwalk site. It's hosted on Google Code, and the latest version, you can install it. If you're using Debian or if you're on Backtrack, there's a nice little shell script written to install it. So you just run that, and it's all up. And also, you can then use binwalk anywhere. Like, for example, I can just type binwalk right here, and it already runs. On the default version of Backtrack, this would not work. I would have to go into the binwalk directory, unless I made it work somehow. Anyway, so if you want to try this at home, and please do, you can download the firmware online. It's not very hard to get it, and try with any kinds of DVRs and see how it is. And with binwalk, really, it's super easy. I mean, you guys saw how I used binwalk -me to basically automate the entire process. Like, I don't even have to know anything. I just give binwalk the binary firmware file, and it does all the work for me. It extracts everything, and basically all I have to do is just search for the string root. I mean, how much easier can it get? So binwalk's a really, really cool tool. And I definitely recommend it on any pen testing. Well, pen testing, any forensics or reverse engineering computer. And OK, another show of hands. How many of you like my background wallpaper? Oh, I like it. 45. How much more time do we have? OK, show of hands. Who's waiting for her to come back? And it's 0. OK, guys, one more minute. One more minute. 1 minute. Okay, let's run John. John's going to run for 3 hours, so that's fun. LS in Windows. Let's run John. Come on, come on. Thank you, everyone. And thank you. I hope you enjoyed this show. At least the end. And have fun reverse engineering firmware. And keep this in mind next time you pass by security camera. And now, wait, don't clap yet. Will she come back another time, or was that it? Sorry. OK, well, this is my slideshow. Demo. Well, basically did everything. Oh, yeah, thank you for your attention.